this will actually be our LinkedIn post with a link to this video. So again, I really appreciate everybody's time for joining. And Jim, you can go ahead and introduce some of your background if you'd like.
Sure. And is everyone seeing the title slide of the presentation, just to make sure?
Yes.
Okay. Well, I'm Jim Parham with Trude Environmental Solutions. Also, the presentation we'll be talking about today is some work we did on the Chattahoochee River down near Atlanta, Georgia. And as Brett mentioned, this was a presentation at the National Stream Restoration Conference just a few weeks back in Baltimore. And my co-author for that presentation was Annie Couch with the National Park Service. Now, she's not in this one, so she's not a co-author, but I need to acknowledge that she was involved heavily in this project. And the sort of end of this presentation about the restoration work that was done in the Chattahoochee River National Recreation Area was work that she did along with many other people, but that she was involved in. So we'll go through the part where we were involved in terms of the assessment and mapping, and then how that was used to actual result in on the ground restoration, which is an excellent approach. Annie is a hydrologist with the Planning, Resource, and Education Division with the Chattahoochee River National Recreation Area in Sandy Springs, Georgia. And so what you're going to see here is very typical of our projects. We work very closely in partnership with many other organizations and local river keepers or users that would actually be using the data for restoration. So while we'll show this one on this is sort of a typical approach that we use. So with that said, I'll begin this presentation and say thank you for everyone for attending. I see folks are still coming in, but that's excellent. This is on the high definition stream survey of the Chattahoochee River National Recreation Area. I'm Jim Parham, Brett Connell is it, and Dane Schumann, all with Trude Environmental Solutions. We're the authors on this work. I'm going to jump immediately to, sorry, I'm getting pop-ups and things going on mine. Okay, apologize. All right, here's a quick image of our high definition survey platform, what we're seeing from the field. This is on a tributary called Crayfish Creek, which we'll be talking about in this presentation. And you can see video of all the sides and a map locating where we are during this survey. And I just want to say this is videographic and a lot of other information, which we'll go into here. And then how is it actually used? So high definition stream survey, or HDSS, is a fast inventory and assessment method. We did the main stem of the Chattahoochee River and the 6 tributary streams, or about 50 miles with 2 surveyors in 5.5 days. So this is complete survey at about 1 meter resolution throughout the system. It was also done using backpack systems, single boat systems, and dual boat systems, depending on the size of the river. The main river was a large river, so it was dual boat. Some of the creeks were large enough for the kayaks to run down, and other ones were small and needed backpacks. So the great thing about this system is we can go from the smallest streams to the largest rivers. All of the sort of systems work together, so you get an integrated output. And then the map on the right is the Chattahoochee River. This small little map here, that's Atlanta. So Atlanta would be right down here, and the giant growth in Atlanta is having a big impact on the Chattahoochee River. How do we collect the data? As I mentioned, we have backpacks. Here's Brett right here coming up one of the streams in the Chattahoochee National Recreation Area. We have kayak systems on the smaller waters, inflatable boats that can run on the larger waters. We also have tablets and water quality testing in places that may have some other restrictions to access. And in some cases, we can integrate this work with drones where necessary. What data do we collect? A very straightforward question. It's important to note that as we're going down the river, this actually is from 2012 with Brett right there and his major professor at University of Tennessee going down a East Tennessee River. But we have video shooting off to the right and left, allows us to see the stream bank and riparian conditions and infrastructure. Front video that allows us to see the habitat types and canopy cover. Down video and multiple sonars showing depth, imagery, substrate, and other things at the bottom. A water quality sensor that's recording the sort of standard suite of water quality parameters such as dissolved oxygen, pH, temperature, conductivity, and other things like that. We can use an acoustic Doppler profiler to allow discharge, bathymetric information to be collected on transects and things like that. Stop and take water quality grab samples for things like eDNA or more specific water quality assessment. And all of that is integrated with the GPS, which gives us the time, location, and elevation, and it occurs at every second. So while we in general say this is about 1 meter resolution, it's much more accurately described as 1 second resolution, as all the information coming in gets categorized and organized to each second of the survey. One of the other nice things about this is the spatial metadata. In other words, the location, the GPS information is integrated within the video. So here's Hawk Creek tributary on the Chattahoochee River, and you can see a little parking lot there, and there's a bridge. The little yellow dot is the surveyor walking up the stream. But if you wanted to see the condition of the bridge, you can just click on your GIS system, and there's the bridge in the forward view of the video, and you can see us walking up the stream towards it. So this is completely integrated with ArcGIS, QGIS, remote geosystems, whatever the preferred platform that you would use. So you're able to go back and review the videos, see the information in your GIS very easily. But this is not just a videographic survey system. The intention of this was how to get the information we need for management in a format that's easy to use for management. This shows an example here where we have 5 colored lines coming down through a survey, and the red here would be the left riparian zone. The next line in would be the left stream bank, then the stream bed, the right stream bank, and the right riparian zone. So you're able to see from one of these surveys in very easy color, red being bad and green being good, what was good and bad in your system. And that continuously goes down all the survey areas. So this would be our continuous data, but we also collect point data the whole time. And so these points would be things like outfalls or bridges, tree falls into the stream, areas of high sediment concentration. Anything that is basically a point feature is also captured. So we have all the continuous data with all the point data, and then that's combined into a system where we can look at something like functional uplift, where green would be areas that if you restored, there's not that much difference from the current conditions to what you could expect the natural conditions to be. And areas that are red are areas that have very high potential for gaining functional uplift or gaining high quality stream where it's currently low quality. So as you look at a large area, it's very easy to see areas that could use some help in the stream. So it takes this videographic information and combines it quickly into a very useful management format. Oops. And then all of the sensor data is linked in your GIS. We have the time and latitude and longitude are built right into the window here and into the spatial metadata, so you can see the conditions. And all the scoring is the color system in your GIS. So you have the data in video, you have the data in map format, and you have all the information in data format. So you're able to use it in multiple different ways to do modeling, to do presentations, to do basic just quick assessment from a single platform. Just covering some of the things we collect, This is the Chattahoochee River again coming down here. We get continuous water depth. We have habitat type, so that'd be riffle run pools, and they're classified through the whole system. Bottom roughness, you can see the condition of the bottom. So this plus many other things is sort of digitally collected as we pass down the stream. As we talk about bottom roughness, we also collect this underwater habitat, and the side scan sonar and video shows this. Here's an example going around a bend in the river, and you can see areas that are coarse and areas that are fine. And that can be confirmed with the underwater video in water that's clear enough to make sure that our classification is correct. Or in smaller streams, our down-looking video gives that information as well. And to show you how sort of accurate and useful this information is, here's a project from Alabama on the Coosa River. And you can see this little notch in the river. This was in 2018. It's actually a large boulder sticking into the stream. Here it is in 2021 in the exact same location. But most of this area was sediment filled and smooth. And now it's mostly coarse. All of the sediment has been swept out of the river and moved downstream. Now, this was important because this project was looking at an environmental flow change to try to improve the habitat for endangered mussels. And one of the things was to try to get some of the sediment out of the river. So you're able to document and determine the change over time with this type of information. We also have water quality running, as we mentioned. And here's an example coming down the stream, and at this location, a tributary flows in with a water treatment facility that has sort of been chronically out of compliance. And you can see the change in specific conductivity going down the river. So it allows you to see where these impacts are coming into the system and how much the change is. You may notice these red points and wonder what those are. Those are when the sensor is out of the water, because this river was full of log jams, and we would pull the boats over the log jams and the sensors would come out of the water and then go back in again. So it also shows us that. What do you get when we do a project like this? Well, you get the stream view video that provides the imagery, the sonar, the mapping. All of this is tied to the GIS data. So all of the layers and styling and all that information we're showing comes in. And then a report, which we're going to talk about following up here, to show all the information in paper form, so that in any of these things, whether you want to use it in the GIS data systems, whether you want to use it as imagery, or just figure out what the answer is, it's available. So with the Chattahoochee River, how is this actually used? As we say, it was intended not just as imagery, but as an approach to make decisions, to make management more clear at areas to do restoration. Here's the park as a whole. I know this is kind of small, but it doesn't really matter. I really want you to see just the colors. This is all the scores combined. This would be the riparian. The next one will be the stream bed, or the stream banks, and then the stream bed. So if we were talking about this whole 50-mile national recreation area, we'd be able to look at its overall conditions, see what the areas that are having the most troubles, and also compare it to other parks or other areas to see which areas are doing better or worse. So one way of looking at it is, what is the condition of your overall system, which would be something you can look at over time also. Well, we may also want to know, is there a difference between the river and the tributary conditions? Here's these same bars, so combined riparian, stream bank, stream bed, but the river is on the left and the tributaries are on the right. So we can see that overall the river is in better condition than the tributaries, and the stream bed and stream banks are where most of the problems occur in the tributaries. The National Recreation Area divides their segment into 10 different management areas. Because this is a GIS-based approach, it's very easy to delineate all kinds of different sections and breakdowns of your data. So we're looking at the 10 different management areas, the same part combined, riparian, stream bed, or stream bank and stream bed, and you can see which areas of the river differ and may have some issues, and overall what those issues might be. So again, if the question is which area here is having problems, you'd be able to tell that. And then similarly, we could also look at the tributaries. Again, we sort of saw the difference over here. This is the comparison again, if we're looking at these two slides, but here's each tributary broken down into the overall riparian stream bank and stream bed. And you can really see some stream bank and stream bed issues, but you can also see that the tributaries are not all the same. So where are the problems? This multi-scale assessment framework is provided so that you can quickly see what the issues are and then document them in your different sections. And it follows down not just from that big scale, but all the way down to the sites of concern. What areas would need some attention from the managers? Here's an example. There's 3 different areas noted on this creek, and you'd be able to say, okay, what are those? Okay, we have them mapped. Here's sites of concern. What does that mean? Well, we were requested by the National Park Service and other clients to simplify all of this data into a single output. And so we created these sites of concern. This is Crayfish Creek that we'll be talking about. I don't expect you to be able to read this, but what you get is a site overview, a map, the site metrics of why it scores the way it does, a photo of the issue area, what the problem is, what the likely cause of that problem is, what your restoration approach should probably be, how difficult is the access, and the overall correctability. So in a sort of single page or a 2-page output, managers would be able to look at this, take it to meetings, talk to people, hand out different sites of concern, and try to generate a group of people who are interested in the same thing. So this is Crayfish Creek, and I'd like you to see this one little thing that was in the sites of concern. With the screen point features and functions combined, the overall condition of Crayfish Creeks indicated that this stream has one of the top 3 worst scores of the tributary sample. So this is an example of, after surveying 50 miles, here's one of the top 3 worst locations. And this is one of the reasons that this area was then selected to have a restoration project. So this is sort of when I would normally switch over to Annie, but I'll take this part. We provided sort of that background of what's going on in the system. She took the information and developed and worked with the local user groups, their river keepers, Trout Unlimited, National Wildlife Federation, local things like the Power Company, Southern Company, all kinds of folks to join together to create this Crayfish Creek restoration project. Here's the detailed survey that was completed on Crayfish Creek to aid in the restoration approach. Here's the area that the restoration was done on. We're walking down, you'll see this big ugly pipe dropping into the water. You can see how much erosion has gone on. The bottom is basically mud now. The stream is cutting down. Tributaries are have a great incised areas coming in. There's lots of problems in this area. The trees are falling in. And so here's the group that got together. They had a huge amount of folks to help. Volunteers came in. Here's a chain of volunteers moving rocks into the creek. On the left side, you can see the geofabric going in after the banks of the stream have been sort of laid back. A lot of folks helped with the planting, and then they ended up with a creek that looks like this. So a much nicer situation, sort of a pretty restoration of a very damaged creek. And the damage was coming from stormwater runoff from all the development and the reversal of flow from the big hydropower. So here's a before after shot. There's that pipe I was showing you in this horrible cut down. Here's the little steps coming in from this creek here. And the overall thing looks really nice now, as this picture was just a few weeks ago prior to this last conference. So the restoration has taken hold and is growing in and done a very nice job. So the overall thing I'd like you all to get out of this is the ability to map the whole system allows those problem areas to be easily defined, and that we no longer have to just go to a bridge and look off, or to boat ramps and see things. The whole system can be surveyed very rapidly. The data can be organized into a very simple to use output, and that output is useful for all types of things. In this case, we talked about a stream restoration project, so we were able to sort of do the corridor assessment, and it led to the restoration. But we can also do this for infrastructure, for stormwater, for transportation projects, water quantity for hydropower, water quality for a lot of different projects. Habitat is something that we've done on many of these projects, looking at the areas of best habitat. Here we're working with Tennessee Wildlife Resources Agency doing that. And it can also be used in outreach with the environmental and nonprofit groups to try to get action to happen. All of this information is done from a single survey. So while we talked about the stream corridor assessment and restoration, all of these outputs could have been done from the survey and used for different approaches. And all of that flows into EPA's integrated planning framework. This is a great example of a project in which we work with many partners. We're typically working with federal, state, or local partners all over the country. I'm in the Nashville, Tennessee office, so you're seeing a picture of Nashville, Tennessee here, and a bunch of rivers that have been surveyed up in my area. But we've worked with folks across the country, power companies, a lot of different municipalities, federal agencies, water suppliers, and larger consulting firms. So this project is a prime example of how we do sort of a partnership approach to get these problems solved. And with that, I'd be happy to take any questions, and thank you all very much for your time and showing up to listen today.
Good deal. Thank you, Jim. That's the first time I've seen pictures of Crayfish Creek post-restoration. Those pictures are great.
Yeah, it ended up really nicely done, and I think we may have a few people who were involved in the restoration here. So like I say, that's not our specialty. We're not the folks who actually rebuild the streams, but it was a very nice job, and a lot of people were involved to get that done. So I applaud the effort that was done locally to restore this creek. Oh, and on one note, they have already seen the trout coming up to use this stream. So the trout from the Chattahoochee River are moving up into the stream to use it to spawn. So that's excellent to hear too.
Very cool. So like I said before, I recorded this presentation, and so we'll be mailing out a link and posting it to LinkedIn for anyone to share, watch again if you need to see this information. But don't hesitate to, we're standing by for the next 30 minutes at least to answer any questions. And then if you and your organization would want an additional webinar focusing on a different aspect of high definition stream survey and the solutions we can provide, we love putting on these webinars, and it's definitely not a problem. So don't hesitate to reach out and let us know that your organization would like one. So with that, I'll go ahead and stop talking so somebody can ask some questions. Let me hear what you got. Go ahead, Joanna.
Hi, thanks for the presentation. It was really interesting. I was wondering how you QC the data. I mean, it looks like it does a pretty good job of giving you a lot of details of the stream bed and things like that, but do you go back and spot check every so many feet, or how do you kind of verify the data that you're collecting?
So that's a great question, because the QA/QC happens at many levels. One of the levels that maybe you're talking about is, do we return to the field and measure specifically information to see if our classifications fit those? we have publications on that topic, and there's high correlation between that. So we have a pretty good confidence now that the process works. We also typically collect transect data within this process. I wasn't showing that so much today because that wasn't sort of the focus of what this is going on, but the transect data allows us to check this. A lot of the sonar information, for example, will get the depth coming right out of the sonar units, but we also have the sonar sonogram, the actual data coming out of it, and that can be quality controlled. So from the field data, we're able to quality control with multiple different pieces. Then we move into the whole classification side, in which we have defined sort of standard operating procedures in terms of what would classify into what area. What is this? What is a failing stream bank? What does that look like? What is one that's not as bad, but somewhere in the middle? What are those things? So there's imagery and definitions for all of this, and that classification gets done, and then that returns to a random sample in which a different classifier comes through, usually going to be myself or maybe Brett, that have a lot of experience with it, would come back through and make sure that the classified areas are in agreement with what our experience would say. So we have a second level that gives the sort of how accurate is the information in terms of a random sample of the overall survey. So we get that, and it has to reach a certain level to allow it to be turned over to the client. So that level comes through here. And then at the same token, the beauty of the imagery is it doesn't require all of our classifications. You may say, well, we don't agree with that. We'd like to look at the imagery ourselves. And that's the beauty of it. It doesn't require us to be the one to do that. We typically would do that for the client, but it allows anyone to review it. So we've had many cases where we serve as technical help in a lawsuit, for example, with the, in a power company is being sued by someone because they're not in compliance. Well, we're able to show exactly what is there. So is the contention that this is being caused true or not true? It's very easy to see. Both sides can have all the data and look at it. So from the highest level of quality control, all of the data is reviewable by all parties. So it's an excellent way to actually get the information out and allow multiple people to look at it and see if they agree on what the bad areas are and what the problems are caused by. Does that answer the question?
It does. Thank you.
And I will also add to that that question has been something that we've been working hard on for quite a few years, because we're trying to take large, complex data sets and reduce them to a very simple output. That question is very important so that that simple output is accurate. And one of the great things, and it's something that Brett did his graduate work on, maybe should let him talk, but looking at the Dave Rosgen approach, for those of the folks who know about him, and the bank erosion hazard indice, in which there's all these measurements being made to determine whether these banks are, what the condition of your banks are. The video imagery does an excellent job of replicating that, but also in a very simple form. It's easy to see what's wrong with the stream banks without going through high detailed measurements. And Dave Rosgen's work, which is, excellent, and his books and all of his publications are top notch. That was he had tape measures and basic equipment when they were developing these things 40 years ago. So now we have a whole new set of ways to record information and get basically the same answer that he was seeing with very detailed transect information, which required lots of time to collect. And so now in a fraction of the time, we can get the whole system mapped. Yeah, thanks for that question. Any other questions?
Chris, I kind of want to call you out since you're a Chattahoochee River keeper. Do you have any thought on the presentation or what we're doing?
Yeah, I mean, appreciate what y'all are doing and how that has helped get, I guess, the crayfish project set up. I know Jason, the riverkeeper, was, took part in a lot of that whole process. I'm curious in how this has been used. This whole process has been used aside from restoration projects. I'm trying to think like what other applications this could have. And Jim, I guess you were kind of alluding to that. I guess maybe it's been used in litigation. So I'm kind of curious what other applications this has, just strictly beyond a question of restoration or identifying restoration projects, as the National Park Service was able to do with a good bit of precision.
That's a super question. And I think this presentation was focused as a stream restoration conference approach. So that question is excellent. I'm going to back up here in these slides a couple and just say we do a lot of work with stormwater and sort of the MS4 community. So many municipalities who are looking at their storm sewer system and the impact that it's having on the streams. So this is an area in which a lot of this is directly translatable for. So the stormwater community, we do a lot of work with the stormwater community. We do a lot of work with hydropower because the peaking from hydropower, so you generate power by letting water go through the turbines. That creates electricity, which is great, but it also creates a higher flow down below the dams. And that peak flow can have negative consequences on the river below. And what are those consequences? Where are they? How bad are they? That's something that we do a lot of work. So the impact of hydropower and its throughout these systems is something we work on a lot with both sides of that. And again, we work with both sides, the power producers and so the environmental community that's trying to minimize impacts, because the output is so easy for both of them to use. We do a lot of water quality studies. I think I alluded to one with an out of compliance water treatment facility. So we do a lot of water quality projects. We just are in the process of completing, have already completed the surveys, one for an abandoned mine land project where they had, they knew there was water quality problems within the watershed, within the whole stream network, because they could see that signature showing up, but they weren't sure where they were coming from. So we surveyed 250 miles, everything from the main river up into every little tributary with water quality and imagery. And we were able to see exactly where these problems are coming from. So if we're talking about something like mine impacts, it also works for that. We've used it with TMDL planning, sort of that total maximum daily load, which is somewhat of a stormwater issue sometimes, but also for a lot of other reasons. So water quality issues. Another area that we do a absolute ton of work, and sort of the area that's sort of near and dear to my heart as a biologist, is habitat. The information you saw, the depths, the type of bottom or cover, the riffle run pool classification, how much sediment is on the bottom, embedding the bottom, what is your in-stream cover, your riparian condition, allows us to make very detailed maps of habitats. So we've done this for trout, we've done it for muskies, smallmouth bass, multiple small fishes, darters and gobies, and endangered mollusks, where the core habitat data is now available. So it's very easy to create a suitability model, which then can be overlaid on something like this assessment. And you can find areas that are not only good for restoration, but restoration that could return habitat. So that's something that happens a lot. And then the outreach side of this, we were in discussion with Tennessee State Parks, and that they wanted to add this information into a kiosk so that at a state park, people who are not able to kayak hundreds of miles of river and see it all are able to go out and do virtual tours. So it sort of flows into all of this. We do a lot of bathymetric surveys that support site assessments for things like drinking water intakes or outfalls. So the detail and the specificity of the data can be very high, so it can be used for all kinds of information. But again, most of the times the projects are focused on one of these areas, but the beauty is that this data that's been collected on many projects, 2 or 3 years later, someone calls back and says, well, what about this? Could you do this? And we can take that same data set and find out what the habitat was. So I guess that's a very long answer to say it can be used for all kinds of stuff. And the strength of the approach is that it's not a specific assessment only for restoration or an assessment only for water quality. It allows us to look at water quality, habitat, corridor assessment, infrastructure, water quantity, all in a single pass, and therefore integrate the multiple use issues that most of our streams and rivers have.
Thank you.
Yeah, great question.
Thank you. Well, if there's no other immediate questions, don't hesitate to email us if you want another meeting, anything. But I'll be sharing this recorded video link with everybody later. So either way, I think we got up to 23 people at one point. So that's a good success for us. I'm happy everybody joined, and I really appreciate everybody's time. So thank you, and we can go ahead and leave it at that.
Yes, thank you very much, everyone. It's a pleasure talking with you.